Assalamualaikum and a very good day. We are from Group 7 and we will be presenting about plug flow reactor. These are the group members involved. As myself, my name is Siti Nurdaya binti Ahmad Nazri and my matrix number is TJ19044, and the other members included Nur Ain binti Zuhairi, Nur Eza Shazira binti Idan, Aida Maisarah binti Zalul Hisham. I will be presenting about the introduction and also the calibration curve. But before that, I will state the objective of this experiment. So the objective is to study the effects of mean resident time on the conversion factor of saponification, reaction of ethyl acetate and sodium hydroxide in plug flow reactor. Plug flow reactor is a model used to describe chemical reaction in continuous flowing system of cylindrical geometry. It can also be called as a type of continuous flow reactor which are commonly used in industrial processing. As all the continuous flow plug flow reactor are almost always operate at a steady state. So it is also used to predict the behavior of chemical reactors of such design so that the key reactor variable such as the dimension of reactor can be estimated. So plug flow reactors are also known as the tubular reactor, consists of cylindrical pipe with the opening on each of reactants and product to flow through. So in PFR, the model works well for many fluids. So for example, liquids and gases. Although the turbulent flow and axial diffusion causes a degree of mixing in the axial diffusion, so the PFR model is appropriate for this type of effects because it is sufficiently small that they can be ignored. In a plug flow reactor, one or more fluid regions are pumped through a pipe or a tube. So the chemical reaction proceeds as the region that travels through the plug flow reactor. That can be focused on the reaction is saponification, which is a process which involves the conversion of fat, oil, lipid into soap and alcohol. So by the action of heat present in the aqueous alkali. So for example is sodium hydroxide. Soaps and salts of fatty acids which are mono and have a long carbon, at least 10 carbon. So one of the example is sodium palmitate. Next is the calibration curve. Calibration curve can be defined as a general method for determining the concentration of a substance in an unknown sample. So by comparing the unknown sample to a set of standard sample of a known concentration. So calibration curve can also be used to understand the instrumental response to an analyte, can predict the concentration of analyte in a sample. Next, my friend will be presenting the next.
Assalamualaikum and a very good day, Doctor. My name is Nur Ain binti Zuhairi. My ID number TJ19049. In this video, I will talk about the calibration curve of conversion versus conductivity. A calibration curve for conductivity versus conversion is prepared for saponification reaction of ethyl acetate and sodium hydroxide. Conductivity is inversely proportional with the conversion. When conductivity increases, the conversion will be decreased. For the calibration curve of conductivity versus conversion, the slopes and y-axis intercept value is determined from the equations of the curve yield. Based on the graph, the slopes is equal to negative 0.0424, while the y-axis intercepts is 0.9408. Based on the graph, we can relate the conductivity and conversion into linear equation where y is the conductivity, x the conversion, m is the gradient, and c is the y-intercept. The gradients of the graph we can calculate by using the formula m equal to y2 minus y1 over x2 minus x1. Next is the graph of conversion against residence time. The x-axis is residence time in minute, while y-axis is conversion in percent. Residence time refers to the time taken needed to process one volume of the reactor fluid at entrance condition, whereas the conversion refers to how many moles of product are formed for every moles of sodium hydroxide consumed. In this graph, the conversion of reaction is directly proportional to the residence time of the reactant in the reactor. It shows that when the residence time of the reactor increases, the conversion of the reactant will be increased. Residence times show that the average amounts of time that a particle spends in a particular system, and the conversion is direct functions of the time spent for reaction. Three values of conversion which are 0.0% at 6.667 minutes, 0.7% at 8 minutes, and 1.6% at 10 minutes is recorded from the extrapolation of the graph. The formula that we use to calculate the residence time is reactor volume divided with the total fluid flow rate.
Assalamualaikum and a very good day. My name is Nur Eza Shazira binti Idad with ID number TJ19074. In this slide, I will present the other parameter which can use to monitor the reaction in plug flow reactor. For the first one is temperature. By increasing the reaction temperature will increase the reaction rate, diffusivities, and mass transfer rates. Besides that, temperature also affects the equilibrium constant, whereas the higher temperature increases equilibrium constant for endometric reaction and it will decreases the exothermic reactions. Also, by increasing the temperature will reduce the cost of reactor as shorter time is needed for reaction to take place. Next is we can use catalyst to monitor the reaction as the other parameters. A catalyst is used to increase the reaction rate by lowering the activation energy without being consumed in the reaction. The use of catalyst imposes operating condition constraint as the catalyst must maintain activity for a period of time between catalyst regeneration. Instantaneously, by using catalyst, it will increase the rate of conversion in the reactor, resulting in improvements of reagent conversion and yields of product. Lastly, the next parameter which we can use is pressure. Increasing pressure for reaction that take place in the gas phase increases reactant activity and thus the reaction rate. Reactor yields follow Le Chatelier principle, whereas for reaction that increase number of mole lower pressure will increase equilibrium conversion. For reaction that decrease number of mole lower pressure will decrease equilibrium conversion. Thus, by monitoring the increasing pressure of gas-liquid reaction, increases the solubility of the gas in the liquid, which eventually increases the reaction rate. There are a few advantages of turbulent reactor, which is 1. Good for studying rapid reaction. The second one is good for large capacity processes. And lastly, it has a high conversion rate per reactor volume.
Let's continue, shall we? Assalamualaikum warahmatullahi wabarakatuh. My name is Aida Maisarah binti Zahra Hisham. My ID number is TJ19048. Number 4. What are the differences between tubular reactor and continuous stirred tank reactor (CSTR)? First, CSTR maintains same concentration at any point in reactor, while tubular reactor has no actual mixing but only radial mixing. Next, CSTR reduces concentration of reactant less than tubular reactor. The third one, tubular reactor gives higher conversion than CSTR for positive order reaction, while in negative order reaction, CSTR is preferred. The last one, CSTR provide higher flexibility in terms of various processes and reaction, while tubular reactor provide higher efficiency than CSTR of the same value. How can you know that the reaction has reached the steady state?
When a reaction involves one or more intermediates, the concentrations of one of the intermediates remains constant at some stage of the reaction. Thus, the system has reached a steady state. This means that there are no more changes occurring to the reactions. That is all from us. Thank you for your time.